What's up, physics? Live from the dirt bike shed. There I am. Hey, I'm going to talk to you about what you can expect on your test that I'm going to give you, all right? Number one, remember this video? This is where we start. It's where all our test stuff's going to start. Right here. See that handsome man? He's talking to you about F is equal to ma. And we were talking about Newton's 3 laws, okay? And they are 1, 2, and 3. Number 1 is inertia. That means you're going to be doing what you're doing. If the spaceship is still, it's going to stay still. If it's moving, it's going to keep moving. Number 2, F equals ma. We'll do some math problems with those, with F equals ma. And then number 3 was for every action, there's an equal and opposite reaction. And I'll ask you questions about that. Now, how did we do this in class? When I pushed and pulled on objects, okay? That's the first thing. The next thing we did was a short quiz on F equals ma. F equals ma. And that has since expired, but I'll give you a couple of examples right here. Force is equal to mass times acceleration. If you push with 50 newtons on a 1 kilogram mass, then it will accelerate away at 50 meters per second per second. That's F equals ma. Okay? If you have a 100 newton object, if you put 100 newtons of force on a 0.5 kilogram object, then it will accelerate away at 200 meters per second per second. F is equal to m times a. Very simple. The next thing we need to know is that when we talk about F is equal to ma, in the downward direction because of gravity, we can just use W equals mg because it's all the same, right? Weight is equal to mass times gravity. Well, the weight is the downward force. Mass is mass. And gravity is just acceleration. So these two are the same. If I ask you how much a 10 kilogram book weighs, you would say, Mr. Perkins, that weighs 98 newtons. Because you'd say 10 times 9.8 meters per second per second. W equals mg, right? So weight is just a downward force. Here's something. If there is, here's Newton's third law. If there is a book, a 10 kilogram book, is going to be pushing down on a table with 98 newtons of force, well, guess what? The table is pushing back with 98 newtons of force. That is the only possible answer. Otherwise, the book would be either moving up or down. It would be either floating or crashing through the desk. F equals ma. Then we talked about kinetic friction. We said, hey, check this skateboard out. Kinetic friction. And we found out by watching the video that this skateboard, even though it's heavy, is easier to move that way because it has wheels. It's very easy to move. Easier to move than this block of wood, this very, very light block of wood. The block of wood, we had to try to move it. It was only 3.3 newtons. But it took more force on that spring scale to move that block of wood because it had friction. It had friction. And the skateboard, it had wheels, so it had very little friction. Okay, so the number or the letter we use for friction is mu. The mu. Okay. Then we did some problems. We said, hey, if this block of wood has a weight downward towards the earth of 3 newtons, and we have to pull on it with 1 newton, what is the mu? Okay? Well, the downward force here times the mu is equal to how hard you have to pull sideways. It's equal to the sideways force. Okay? So in this situation, this 3 Newton block can be pulled with only 1 Newton. So you would say, okay, the mu is equal to now the sideways force divided by, we're going to take this right here, see, we're going to take that, going to move it down there, divided by the weight, or the downward force. So for this one, the mu was 1 Newton divided by 3 Newtons. So very simply, the mu is equal to 0.33 for that block of wood. And that's a pretty high mu, actually. Then we did a worksheet that looks like this, and I'll answer some of these problems for you. We did a worksheet that looks like this. Okay, the coefficient of friction is unitless, and it's called the mu. The abbreviation is a backwards u. And then we tried a problem. A 5,000 Newton golf cart. Okay, here's a golf cart. It is 5,000 newtons. That's its weight. That's its downward force. And it is pushed with 1,200 newtons. It takes 1,200 newtons to get that thing to roll. Okay, so we have to push it with 1,200 newtons. Then what is the coefficient of friction? Its wheels against the ground. Very simply, we would say the downward force, 1,200 newtons. The sideways force is 1,200 newtons, divided by how much it actually weighs is 5,000 newtons. Punch that into our calculator. We'll say that the mu of this is 0.24. 0.24 is the mu. And there are no units with the mu. It's a unitless number. Let's try this other one down here. Let's slide down. And most of you got these right, okay? So skip forward this part of the video if you want to. You have a 7,500 Newton refrigerator. Okay? All right, that's its weight down. It's got a mu of 0.12 against the floor. All right? You got to push on this thing pretty hard to get it to move. How hard would you have to push? You'd have to push with the downward force, the weight, times the mu, times the frictional coefficient. So we would say 7,500 newtons times only 12% of that. So let's see, 7,500 times 0.12, 900. This refrigerator is resisting being moved with 900 newtons because it's kind of stuck to the ground there and it weighs 7,500 newtons. So how hard would you have to push? You would have to push with greater than 900 newtons to get it to move. 901 would certainly do it, right? Then we went back and we slid objects. We knew how much they weighed, and we knew how hard we had to pull on them. We could look on our little scale, and we calculated the coefficient of friction again. So it was just like the skateboard and just like the wood. Now, if you notice, all I'm doing is I went back to our oldest homework and I started here at Newton's laws, okay? And then I've looked over every homework since then. Now I'm working my way up to the top. That's all I'm doing. This is how you can study for this test. And on my way up to the top, I've got two other problems. Pushing and pulling objects. And I had to fix that because you couldn't turn any work. And then force on an angle. And that's not due until tomorrow at 5, so I'm not going to give you those answers right now. But this is pretty much how the test is going to go.